domain, all real numbers. Perfect. Can anyone give us a degree?
2.
When I square x, I get x squared. And when I multiply x squared by x squared, I get degree 4. Perfect. What is the maximum possible number of turns?
1, 3.
Yes. 4 minus 1 equals 3. Meaning it cannot exceed 3. It doesn't have to have 3, but it cannot exceed 3. Awesome. Very good. Now, how many x-intercepts will you give, no matter what?
1.
How many x-intercepts will you give, no matter what? It's always the degree. Always the degree. So I have to find 4 x-intercepts, even if they're all the same. It doesn't matter. Perfect. Good. So how do I find the x-intercepts? So if you want, we can go through the list again. So I determine this, I determine the degree, and I determine the maximum possible number of turns. Yes, say it again.
Plug in y for 0.
Yes. So y equals 0, which means negative 2, x minus 4 squared, x squared minus 25 equals 0. Again, what do you think I'm going to do first? And always keep in mind, factor simplify. Factor simplify. Clean it up.
Back to the x squared minus 25.
Correct. That's good. Into?
X plus 5x minus 5.
Awesome. What else should I be doing?
Doing the x minus 4 squared.
Divide both sides by?
2.
Negative 2. Very good. And this is already factored. Perfect. Remember, dividing both sides by negative 2 will not change any solution. It just clears the number in front. Perfect. So now I'm ready for your 4 solutions. What are those 4 solutions?
You have 2 which are the same.
Which are
4,
very good. I agree.
5, and negative 5.
Awesome. I put them in the chart in order, and 0 must be in the middle. So I have negative 4. I'm sorry, it's negative 5. And I have 4 and 5. I have to write 0 under all these 3. And now I'm going to ask you, what is the multiplicity of 4? 2. What will the function do at the x-intercept 4, 0? Awesome. What is the multiplicity for negative 5 and 5?
2.5. I really don't know.
1. It appears once. Right? Negative 5 is a solution, appears once. X equals 5 is one solution,
I
appears
didn't know
once.
what multiplicity was, okay?
You're asleep then.
Man,
So what is
it
the
must have been when you covered it.
So what is the multiplicity for these?
Again, 1.
That's fun. Okay, so 1. So what will the function do at negative 5 and 5? Cross. I make myself a note just in case I forget. Who knows? And it's a regular cross. Okay. So here's what we have. This is done. This is done. This is done. This is done. Now I want the y-intercept. Slightly more difficult, right? So let's do it together. 0 minus 4.
Negative 4.
Negative 4 squared.
16.
Okay, so this is 16. 0 minus 25.
Negative 25.
The negative 25. And times negative 2. How much is negative 2 times negative 25?
50.
50. Perfect. 50 times 16. 5 times 16 is 80.
800.
800. So let's write it here for everyone to see. We determined f of 0 as being negative 2 times 16 and times negative 25. 16 times 50. That's how we got 800. Okay, so now this is done. Done, 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 done. No symmetry we'll talk about in a minute. And behavior. Okay, which degree is this? Odd or even?
Even.
Good. Does it have a positive leading coefficient or a negative leading coefficient?
Negative.
Negative leading coefficient. So then what is the end behavior?
The negative is going to be right back down to it again.
Okay, so follow my hand for a moment. That's all we need, the chart, and I'm going to specify the symmetry in a minute. So that's all we need, not 15 pages. Don't waste your time, but that's all we need, the chart. Let's do this. From negative infinity, it will cross at negative 5, 0. It will continue somewhere 0, 800 and cross the y-axis. I don't know where. But it has to come back to the x-axis at 4, 0 because it has a turn there. It has to turn again. Why? Because it comes back at 5, 0 and crosses and goes to negative infinity. Maximum number of turns, 3. You cannot have more. One more time. From negative infinity, it crosses the x-axis at negative 5, 0. It continues to the y-axis a lot, 800, 0, 800. It has to turn. That's our first turn. It has to turn because it has to come back to the x-axis and turn at 4, 0. It turns at 4, 0. It comes up to some value, maximum again, but it has to come back and cross again. So one more time. Once has to turn to come back to this turn, and then it turns again because it has to come back and cross at 5, 0. So let's see the graph. Here it is. That's all I need. Nothing else matters because I have summarized everything in the chart. Okay. So I have to plot negative 5, 0. I have to plot this, and you'll have to 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say this is 800. 4, 0, and 5, 0. So I plotted negative 5, 0, 0, 800, 4, 0, 5, 0. And now I'm reading the chart one more time. Ready? From negative infinity, it has to cross a regular cross. I don't know where it's going to turn. I don't know if it does this. It's more likely. I don't know if it does this. Possible. That part I don't know. I have to use the calculator, but first I have to think about the graph. So I'm going to say that it's this case. I don't know. I haven't graphed this function. We'll check in a minute and we'll make a correction. Again, it's very possible it does this. So then it has to come down to 4, 0. I don't expect it to turn at 0, 800, but that's because of experience. I don't expect it to, but it can. It's possible. And now it turns at 4, 0. It has to come to another maximum and has to drop, crossing the x-axis regularly at 5. I don't know how high this is, no idea, and we cannot do this in this class. We do it in calculus. In calculus, we graph these functions with absolutely no help from any calculator. So this is the function negative 2, so f of x, negative 2, x minus 4 squared, and x squared minus 25. Now the moment of truth. Let's go to the y equals, clear. And we put in negative 2, in parentheses, x minus 4. It was x minus 4 squared, correct. X minus 4 squared. And then parentheses, x squared minus 25. Okay. I know the viewing window has to be adjusted because the y-intercept is at 800. I know I don't really care about the negative part of the y-axis. There is not a lot of action there. I know the graph. There is no need to go any further than -5 here. But there is absolute need to go above 800 here, maybe even 1,000.
It's 1,200.
So we'll see in a second. So we can adjust it later. That's okay. So x minimum, the left side, I'm going to say -7.
You're still in the graph.
Oh, I'm sorry. Forgive me. Thank you. Sorry about that. So -7. X maximum, I don't care to go too far beyond 5. So I'm going to say 7. Scale of 1 is good. Y minimum -10, no, that's too far down. Y maximum, definitely 1,000. And a scale of 200. It may not be enough. I have no idea.
Should go to
I don't understand why the graph does not appear here. Large screen. Ah, here it is. Okay, so we go back. We adjust to 1,500.
to 2,015. I'll show it.
Okay, very good. Thank you. Good. Thank you so much, Alex. Ah, this is what we expected. This is a lie right here. We know it's a lie. We're going to get to it in a minute. So it's coming from -infinity, crosses at -5, 0, goes to a maximum as expected. How did I know? I haven't graphed this function. How did I know that the maximum will be on the left and not on the right? Because if I need to force my pencil to graph or my marker to graph the function, it's not right. So it has to be very smooth. All these polynomial functions are very smooth. If I have to twist my wrist to graph it, most likely is not good. Okay, so I can determine this maximum now and put it in my chart between -5 and 0. Second and calc, maximum is 4. And I have it between -5 and 0. Give me the maximum because I don't want to guess. Okay, so I'll put it in my chart. It's at -2.67. -2.67. And it's 1590.1. 1590.1. So that's the local max. It happens that this is the absolute max as well. Now, I want to go on this side where I know the calculator is lying to me. And I want to go to the viewing window. And now I want to look at between 0 and 7. Not even that far, but that's okay. Y minimum -2, but Y maximum only 4 with a scale of 1. Show me that little bump. Ah, I see it.
Because it's so incredibly small.
Right.
Show it
Exactly.
at that scale.
So I knew that had to happen because we already had the graph. So it turns at 4, 0. It goes to a little maximum, tiny maximum, and comes back and crosses at 5, 0. It's expected because we did all our work. So now I can determine this little maximum. It's between 4 and 5. So second and calc, maximum is 4. Between 4 and 5, I don't want to guess. 4.67. 4.67, and the maximum is 2.87. And now I really know everything about this function. So this is the local max and also absolute. There is no other value higher than it. And this is the local max as well. The local min is clear. So this point is 4.67, 2.87. And this one up here is -2.67, 1590.1. Okay, let's choose another, any degree you want. Is that okay, Brendan? Are you okay with that?
Yeah.
Okay. Please choose any other degree you want. Odd, even, any degree. 3, 4, 5, 6. I don't think we should go beyond 6, but it's up to you. Any degree. And of course, I should mention, it's very clear, f of negative x does not equal f of x, and it does not equal negative f of x. Obviously, this function is not symmetric with respect to the y-axis, and it's not symmetric with respect to the origin. Not symmetric. We like functions to be symmetric, but they're fewer that are. Okay, any degree you can think of. Anyone would like to pick a degree?
I want to say 5.
Okay, I'll pick one, and you'll tell me what the degree is then. Okay, let's look at 62. Any questions for me, please? Any questions? And then I would like to look at a word problem. 62. So you see the applications of this. Negative 3x squared. Oh, is it x squared? No, it's x cubed. Okay, x minus 1 squared. And x plus 3. Degree, please. Other than Tom. Anyone would like to tell us a degree? Yes, I agree. 3, 2 in here, and 1 here. 3, 2, and 1, degree 6. Awesome. Max possible number of turns. It cannot exceed 5. Awesome. Degree, please. Domain, please. I'm sorry. Forgive me. Very good. And behavior, please. First of all, think, what is the degree? Is it odd or even?
Even.
Right. So for even, one option, second option. Which one is it? Right, because negative 3 is the leading coefficient, and the end behavior will be then?
Right back from negative infinity back down to negative infinity.
Very good. How many solutions will you give? How many x-intercepts will you give for this function?
6.
6, mandatory 6. Good. How do I find the x-intercepts? What do I have to write?
The whole thing equals 0.
Very good. Negative 3, x cubed, x minus 1 squared, x plus 3 equals 0. In other words, f of x equals 0 in order to find the x-intercept. I need to clean it up first. I always clean it up first. How do I clean this one up? Dividing both sides by? Very good. So I have x cubed, x minus 1 squared, x plus 3 equals 0, and I'm waiting for 6 solutions. And the solutions are? 3 of them, x equals 0?
Yeah.
Very good. Indeed.
2 of them are 1.
2 of them are x equals 1.
And the other is negative 3.
Very good. What is the multiplicity of 0?
0.
Very good. What is the multiplicity of 1?
2.
And what is the multiplicity of negative 3? Good. What does multiplicity 1 mean? What will happen here at negative 3, 0?
It'll cross.
It will cross straight ahead. Good. What will happen at x equals 1, 1 comma 0? What will happen there?
Cross and turn.
Just turn.
Okay.
Just turn. What will happen at 0? It will cross, but not like this one. But how? Slow. Very
While
good.
turning.
Odd multiplicity is always cross. Even multiplicity is always turn. So I have to put them in ascending order. Negative 3, 0. then I have 0, 0, and then I have 1, 0. So tell me again, what do I write above negative 3, 0? Yes, just cross. Perfect. What do I write above 0, 0?
Crosses.
But slow.
Yeah.
Slow. Good. What do I write for 1, 0?
Turn.
Very good. Perfect. What about the Y-intercept? How do I get the Y-intercept for any function? I make,
X0.
good, I already have it,
Yep.
right? 0, 0. That's it, I'm done. Please follow my hand for a second. From negative infinity, it's coming up towards the x-axis, and it straight crosses at negative 3, 0. It has to come back, has to have a turn, because it has to come back to the origin and slowly, slowly, slowly cross. It has to come to a minimum. Why? Because it has to come back at 1, 0 where it turns and then comes down to negative infinity. One more time. From negative infinity, it's crossing at negative 3, 0. It has to turn because it has to come back and slowly cross at the origin. Now it's crossing. It has to come to a minimum. Why? Because it has to come back to the x-axis at 1, 0 and turn again, and then come down to negative infinity. Ready? That's all we need. So here's the graph. I have the following: negative 3, 0. I have 0, 0, and I have 1, 0. One more time. Coming from negative infinity, and it straight crosses at negative 3, 0. It must turn. Why? Because it has to come back and slowly cross at 0, 0. It has to come back to a minimum. It has to turn. Difficult here a little bit because they're so close. It has to turn y and come back to the x-axis because it has to turn again and then go to negative infinity. It cannot have more than 5 turns. It has 1, 2, 3. So this is the function negative 3x cubed x minus 1 squared x plus 3. The moment of truth now. And I see the action, everything happens between negative 3 and 3. How high? I don't know. I don't expect this one to be too low because they're so close. So I can graph it with the standard for now. So in y equals clear, and we punch in negative 3, x to the third, and then in parentheses, x minus 1 squared. And then we have x plus 3. I would prefer negative 5 to 5 as the viewing window. Negative 5 to 5. Scale of 1. How low? I already see it here, not too low. So negative 2 is fine. However, 4 should be much higher. So I'm going to put 20 with a scale of 5. And that's not good enough. Okay, I have to go further up. So I'm going to change 20 into 50 with a scale of 10. Let's see if that works. No, it doesn't. It gives me a window here. Okay, so let's go to 100. Still not. Yeah?
150 maybe?
Well, I'm going to go to 200 already. With a scale of 40. Not yet. See, I have this option here with a little, okay. So, okay, I'm gonna go to 300. Okay, again, I know that it's lying here. The graphing calculator is lying to us. We know that. So let's find this. It's between a negative, what was it? Between -3 and 0. So let's find the maximum. Second in calc, I want the maximum, which is 4. I want it between -3 and 0. And I don't want to guess, just give me the maximum. And it's -2.45. -2.45. And it's 288.8. 288.8. Okay. Now I know that I have to look between 0 and 3. So go to the viewing window between 0 and 3. That's all I care about. And Y minimum, -2 is fine. I don't think it goes further. I will see in a moment. And 2 with a scale of 1. As expected, it was slowly crossing at the origin, coming to a minimum because it had to turn again at 1. So this is the local max, and this is the local min. And it's between 0 and 2, with 0 and 1. So second in calc, it's a local minimum, so it's number 3, between 0 and 1, and just give me the minimum. 0.61, -0.4. 0.61, -0.4. I know everything about this graph. Of course, the scale makes no sense, but I didn't know. I wouldn't be able to know by hand. So this is so high up, and this is so small. So this is the local min. This will be the local max, and also the absolute max. And there is another local max here. And I would like to illustrate with a word problem so you can see the applicability of polynomial functions. And then we'll stop. Okay. On page 380, I'm looking at this problem, 75. During a diagnostic evaluation, a 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in heart rate during the panic attack. So, as we see, it's going up, then it's going down, then it shoots up, and then comes down. First question. For which time periods during the diagnostic evaluation was the woman's heart rate increasing? Between 1 and 4, and between 8 and 10. For which time periods during the diagnostic evaluation was the woman's heart rate decreasing?
4 to 8 and
4 to 8,
12.
10 to 12. How many turning points do you see in this graph?
3.
Yes, because you said increasing and then decreasing and then increasing and then decreasing. So indeed 3. Suppose that a polynomial function is used to model this data. What will be the degree of this minimum degree of this polynomial if it has, how many terms did you give me? So what will be the minimum degree? Can it have 10? Yes, but it has to have at least 4 because it has 3 terms. For this model, should the leading coefficient of this polynomial, assuming 4, should the leading coefficient be positive or negative? Negative, because it looks like it's coming from -infinity and going back to -infinity. So it should be a negative leading coefficient. Use the graph to estimate the woman's maximum heart rate. From the graph, what will you say it appears to be the maximum heart rate? 115. Use the graph to estimate the woman's minimum heart rate. Where will the minimum heart rate happen? at x equals 8 or time 8. So roughly about 64 beats per minute. So this is a typical example in which the study of these people, heart rate created all those points that you saw, and they simply connected the points, and they said, oh, okay, maybe that's what this is the function that will model